Hi guys, welcome back to the Techie Garage. Today's episode is a bit of an exciting episode for me because after the last 3 tutorial episodes, we're finally back to a more conversational episode like the first episode that we had in the channel. And secondly, it's sort of a new segment for the channel. And as you may tell from the title, we are going to be doing a book review of The Pragmatic Programmer by David Thomas and Andrew Hunt. And the reason I picked the Pragmatic Programmer to go through it and probably have a review is I was looking for a book to read for this year, and from the reviews I saw on the Pragmatic Programmer, I like the fact that it's a mix of technical and non-technical concepts in the book. So it kind of focuses also on the human side of the engineering world, which I find interesting to read on. And the other bit is on the reviews I also saw it's very relevant for any level. So if you have X number of experience in the software engineering world, or you're just starting out, it's still something that's relevant. And if you read the book again, there are some things that are fresh for you, even if it's something you already know, or you gain a new perspective on that thing. So I thought interesting. So since I'm seeing good reviews on it, and also the fact that the first edition was done in 1999 and the second edition came out in 2019, which is this 20th anniversary edition that you're reviewing, which means a lot of things have remained the same. So I was curious to see. Obviously, they did modernize a few things in the book and removed or added new things, but I was curious to just see like this book, why this book has been relevant for so long. That's over 20 years. And yeah, so I thought it would be great to also do the review on this channel so that and also go chapter by chapter. So today we are going to be doing a review of chapter 1 so that I get feedback from anyone who's read the book before or is currently reading it as per each of the chapters, or I get to hear what people think about the tips that are shared in the book um, easily when it's chapter by chapters, as opposed to just a general review of all the chapters. So yeah, let's get straight into chapter 1 of the book. And I'll be referencing the book a lot. So if I look down in this episode, that's because I'm just looking at the book. Yes. So this chapter 1 of the book is called A Pragmatic Philosophy. And before we even get into the chapter is divided into 7 topics or sub-chapters, if I can call them that. So we can look at what is the meaning of pragmatic before we jump into the different tips from the book, from the chapter. And the definition of pragmatic is dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. So dealing with things sensibly and realistically in a way that is based on practical rather than theoretical considerations. And before I jump onto the things I picked from the book on the different chapters, I want to also read another paragraph that was part of the chapter. And then in this paragraph, the authors were saying what distinguishes pragmatic programmers, and I'm just going to read it out. We feel it's an attitude, a style of philosophy of approaching problems and their solutions. So they think beyond the immediate problem, placing it in a larger context and seeking out the bigger picture. After all, without this larger context, how can you be pragmatic? How can you make intelligent compromises and informed decisions? So that's the idea of what a pragmatic programmer is. And from this chapter, I felt it was more of mindset tips, if I can say that, or a way of looking at things. I haven't gotten to the other chapters ahead, so I don't know if it's still the same thing when it comes to mindset of how you look at things, but chapter 1 was more of the way you think about things and mindset. So I'm going to jump right into each of the sub-chapters in chapter 1 and share what I picked from each of them. So the first sub-chapter is called It's Your Life. And in this sub-chapter, the authors basically talk about agency, the idea that software engineering is a field that gives you as a developer or as someone in that career path a lot of agency. And let me just actually read out the meaning of agency also. So having agency means agency is the sense of control that you have in your life, your capacity to influence your own thoughts and behavior, and have faith in your ability to handle a wide range of situations. So they were presenting the idea that software engineering compared to other careers gives you a lot of control in the sense that your skills can be used across um, things that in other careers might be barriers. So they're relevant across geographical locations. So another example you can think about is as an application developer, a web developer, or a machine learning engineer, or all the things, career paths that you can think about in tech, you can literally be moved from one industry to another and your skills still make sense. So for example, you can work in the banking sector today, you can and move to, let's say, the retail sector, the education sector, you can work for the government, but your skills are still relevant in that new industry. The only thing you need to learn is what is relevant to that domain, constraints and things like that. But programming is just programming. So you're still relevant in that. And that spans across geographical locations. They can be done remotely because it's easy to collaborate as a software engineer. So basically, they were bringing the idea of you have a lot of control of how your career path can go. And they talked about how sometimes people fear change, or you feel like you're in a place where you're stagnating in your job, or you feel like you're in a role that you don't really enjoy, but you're afraid of change. So it was the idea that you have a lot of agency in how your career can go. And actually, reading that subchapter, another thing that came to mind is the fact that as software engineers, compared to probably other careers, you can look at agency also in terms of your consistent learning and growth. You're in a career where, for example, let me use my example as a mobile application developer. If I'm not currently in a role, I can still pick up a random app idea, build it from the ground up, and make sure I'm consistently learning and growing in the things that are happening in the mobile world. I can share that out to the community, the developer community for feedback, things like that. Or I can probably pick an open source project. If I feel like the thing I'm missing the most is probably feedback or having a team where I get to throw in ideas, I can look for an open source project and contribute to that open source project. And with that, I have a chance to interact with world-class developers from all over the world on them reviewing maybe a PR on the open source project that I've picked to contribute to. So you still get a chance to continue learning and growing until you probably land a role if that's how you want to work, if you're not interested in freelance or something like that. So I think it was a very good reminder that you have a lot of agency. So if you are in a place where you're feeling the stagnation or something like that, as they mentioned in the book, it was a great reminder that you're in a career that allows you a bit of agency or control for some of the things that you may not find in other careers. And that was mostly it for chapter one. The first line, actually, for not chapter one, the first subchapter in chapter one, the first line was literally, it's your life, you own it, you run it, you create it. So yes, that is what the whole idea of the subchapter was. The second subchapter is called The Cat Ate My Source Code. And the idea of this subchapter was taking responsibility and ownership from the perspective of you're proud of your achievements and abilities, but you also own up to your mistakes. Your mistakes in the team setup, your mistake in a certain project that you're heading or you're part of. I think it's very easy if you're in a team that is not in a very healthy environment, or even if it's in a healthy environment, to find someone to blame for when things go wrong, when there's like a downtime. So you look for an excuse for it to be, oh, it's not me who did this, or the app, let me just use again the field I'm in. So for example, the app broke down because backend changed this, and vice versa. Backend is like, the backend did not break this. Like we had a downtime because this other team did this. So it's very easy to blame someone else for the things that are happening, but you should also come from a point where if there's something that has happened, you should, be willing to take ownership of what actually you've done wrong. So for example, the app breaking down because backend changed something. You could also, as the app developer, have built something robust enough such that backend doesn't make your app crash. It's robust enough such that if backend fails on its own, right? So it was the idea of being able to take ownership for the things that go wrong, and not making excuses or trying to find someone else to blame. And on the point of making excuses, they were talking about, instead of making excuses, providing options, and providing options from the sense of, say you're being told to do something and it's something that can't be done. So instead of you going and telling this person, yeah, unfortunately we can't do this, think it through thoroughly before you go to probably the person you're going to tell that it cannot be done. So say this is your boss or the person you report to. So X and Y, I can't do X and Y. So think it through in terms of, okay, you can't do X and Y. Why can't you do it? And what are the other options for us to achieve the same thing without these X and Y that you wanted to use? So answer the questions that this other person would ask. And let me just read out the exact passage. They say something like, talk to the rubber duck on your monitor or the cat. Does your excuse sound reasonable or stupid? How is it going to sound to your boss? And an example they give is, for example, you've gone to a bank, or let's say your car broke down and you call your mechanic and they come and they're like, oh, unfortunately, you can't do this. Probably your next question is, why can't you do it? Or what else can we do to fix this problem so that I am able to move my car and get it back home, right? So answer those questions before. By the time you go to this person, you have a more wholesome um, feedback to them, and you're providing them with options. You sound more efficient than someone who will just come and say, we can't do that, and then now they have to be followed up constantly on why can't you do that, what else can you do. So just have these answers already on your fingertips, and just give a more wholesome feedback to whoever you're reporting to. And I don't think there's any problem with someone who's currently just saying that's not possible to be done, and then the other person has to ask questions. That's still okay, but you're more efficient when you're giving that information already, or the person you're reporting you finds you more efficient, or you have your things together more when your feedback is more wholesome and it doesn't have loopholes that have to be fleshed out, if that makes sense. But yes, so the idea is, you can't use the excuses of the cat ate your source code or this and this happened. Provide options and give solutions. And yes, so that was it on the second subchapter. That subchapter is called software entropy, and the meaning of entropy is the amount of disorder in a system. So in this chapter, they are mostly referring to technical debt, and they gave the analogy of a broken window. So there was a research that was done somewhere in a city, and the researchers found out that for most of the buildings, the ones that people found it easier to litter or have graffiti on the walls and all these things, were buildings that had broken windows, or even one broken window, as opposed to a building that is so well maintained, very clean, has, I don't know, walls that look, very well maintained. And if so, if you shift this to technical debt, it was the idea that when a code base has technical debt all over the place and no one cares much about repairing or fixing the technical debt, repairing the building or fixing the technical debt, as a developer working on that code base, you don't think twice about introducing a PR that has very suboptimal code because everyone is doing it anyway. This code base already doesn't look that good. So why should I think so much about, how I design the code or things like that? I can just open a PR that I want to get this fast to production. So let me just open a PR that is introducing technical debt, but it's okay because the code base is just bad anyway. But if you're working in a team where the code base is very well maintained, the team is very intentional about um, working on the technical debt and improving the code base, by the time you open a PR that is just, you just wrote while sleeping, or you didn't care to think much about or designing or optimizing it well, you also will ask yourself questions because someone else in the team will probably check you. So yeah, so the analogy of broken windows. So the idea of this was to say, first of all, do not introduce a broken window onto the code base. Do not intentionally introduce a broken window onto the code base. And if you do introduce broken windows, do not live with the broken windows. So make a point of consciously having ways of dealing with the technical debt gradually and removing it from the code base. So yeah, so that was the whole subchapter on software entropy or technical debt and broken windows. And the fourth subchapter is called stone soup and boiled frog. And in this subchapter, they give the example, or they give an analogy again of soldiers who come back from war, and when they get back to their village, they find the villagers have locked themselves up with all the food that was remaining, and they're really hungry, but yeah, so there's no food because everyone has locked themselves with the food that was remaining. So what they do is they get outside, they build a huge fire, and then put water in pots and then stones inside. So after some time, the villagers get curious and walk out to see what's happening. And the soldiers explain that we are cooking stone soup, that is a really delicious soup that they learned to cook somewhere. But this soup turns out really well if you add like one potato to it. So because the villagers are curious, they go and bring a potato and it's added to the soup, and they're like, oh yeah, and also if you add a carrot, it turns out like really great, the flavor is different or something like that. The villagers are curious, so someone else goes and brings a carrot, and by the end of it all, they end up cooking really great soup that everyone, the soldiers and the villagers, all sit down to enjoy. So, and the point here was being a catalyst for change. So first of all, the soldiers encountered a challenge trying to get food or soup from the villagers, but then they tried to come up with a solution that ultimately worked or got the other team to change their minds, and also unified the village in the sense that after the soup was done, everyone sat down and enjoyed, both the soldiers and the villagers. And in this chapter, they talked about how sometimes when you are, maybe you have something that you feel like would work really well for the team or the code base that you're working on, but if you ask the people concerned with probably helping with this or providing resources or support, you get a lot of pushbacks. Probably we don't have resources for these, probably we don't have the time, it's not a lot of priority, because probably you can see the importance of it, but the other person who's supposed to facilitate it can't see. And there's a sentence they were saying that people find it easier to join on an ongoing success. So show them a glimpse of the future and you'll get them to rally around. So I guess an example of something can be this: there's a feature or something you want to do on a code base that you feel like would help a lot, whether with performance, whether with acquiring more users or something of the sort. If you can build something that proves that concept and shows the results, then it's easier for the other party to provide the support when they can already see results, as opposed to sometimes when you ask for things, it will be a bit of a back and forth. Obviously, not all the time. A lot of the times you ask for the support and you get it, but there are some things that you other people can't see the importance that you can't see in doing that. So come up with something that can show what you feel like is very essential by doing that. Then it will be easier for you to get the support and the resources you need for to pull this through. Yeah, so that was the chapter for stone soup and boiled frogs. So being a catalyst for change. The next subchapter is called good enough software. And in this subchapter, the others were talking about the idea of not being obsessed with over engineering or over refining or building the perfect product or having the perfect code base, because you'll never have the perfect code base anyway. I think every code base, as long as you've written code, has potential to have a bug, or you can't do the best architecture for all use cases, the best, I don't know, all these things. So they were talking about now the idea of good enough software, and good enough does not imply sloppy or poorly written code. Their definition of good enough meant good enough for users, good enough for future maintainers, and good enough for your own peace of mind. So build something, consider these factors in terms of maintenance, users, or how you feel like this is good enough, then put it out to the users. I think, which is the same idea as when you have a product, building an MVP, putting it out to the world or the users or your target market, then based on the usage and what the users are reporting back, refine and reiterate your product. So it was the same idea with now the software that you're building. Don't be too obsessed with having a perfect software. Just build something that's good enough for your users, maintainers, and your peace of mind. And maybe something I can read out is great software today is often preferable to the fantasy of perfect software tomorrow, because as you try to perfect, also that means you take more time putting your app out there or your product out there. So yeah, so a quick analogy probably also from this chapter is programming is like painting. So when you're drawing a painting, you start with a canvas that just with nothing, and then as you continue painting, you'll get to a point where you have a good painting. But if you continue adding more paint onto this thing and over refine, you lose the art of the painting anyway. So yeah, that's the example or an interesting analogy that they were using. So yeah, build good enough software. Don't be obsessed with having something perfect or shiny. Yeah, something great, put it out. And the sixth subchapter in chapter 1 is called your knowledge portfolio, and it's the idea that as a software engineer, your knowledge is your biggest asset. So you should strive to always upskill and make sure your knowledge is relevant to um, probably the year you're in, the field that you're in, the stack that you're in, all these things. And they give tips on making sure your portfolio is okay. So investing regularly in your knowledge portfolio. So for example, reading technical books, upskilling in other ways that you find relevant, taking part in meetups or community groups or conferences, reviewing your knowledge portfolio regularly. So are you using a language that was being used 10 years ago 10, 20 years ago that's not any more relevant? There are better ways of doing it, or an operating system, or just any technology that's not relevant. So reviewing also the portfolio that you have, so that you're not upskilling on the thing that's not even relevant in the industry anymore. The other thing they talk about is diversification. So diversifying your knowledge portfolio. And I think here is the idea of, is it called an inverted T? I don't think it's inverted. There's usually an idea of something called a T-shaped developer, where yes, you're specialized in a certain field. For example, for myself as a mobile application developer, so I have depth in that field or stack, but then I also understand the other things I interact with or other technologies and how they work. So diversification in terms of stack. So you don't have to have built a product with those other things, but you understand how they work. So such that you understand the working of those things. So diversify, know how these other things work. So they talk about also trying different languages. So away from stacks, like play around with different languages, see the difference. So it will give you a different a deeper perspective on a lot of things. And probably I can give an example is when I was starting mobile application development, I wrote in Java, then for a while, then transitioned to Kotlin. So when probably someone says to me, Kotlin is very concise or something like that, I understand what they mean because I've built mobile apps in Java and I've written, let's say, a data class in Java, having the properties, then the getters and setters. Then I've written a data class in Kotlin that has way less lines of code. So I understand when someone says it's very concise and reduces boilerplate because I know what they mean. So if you're able to play around with more things, you don't have to have depth, then it's better than when you just concentrated on one thing. Something that I really found also interesting in terms of the knowledge portfolio, they're talking about critical thinking. So besides staying up to current trends, reading and upskilling, going to meetups and conferences, diversifying and all these things, think critically about the things that you read about. For example, you come across a blog that you're reading about. Let me give an example of something in Android that people have very different opinions on architecture. So if you find a blog that says X architecture is the best architecture, don't just make that your opinion and that's it. So this becomes what you believe. So think critically about it. So ask yourself questions about why do they think that this is the best architecture according to them. So there were 5 or 4 techniques that they were talking about. So ask yourself the 5 whys. So probably why this architecture, why was it developed, who does this benefit, what's the context, so when or where will this work, so is it best for a specific use case, or so what is it best for exactly, and then why is this a problem? So what problem was there in the previous architectures that it's trying to solve? And so all these questions to really understand like why this, or the whole context, instead of just reading something up that was written by probably someone also like you and making it like the truth or the gospel truth or your opinion on something. So I found that really interesting. And the last subchapter is called Communicate. And they really went in depth in terms of this subchapter. So the fact that as a software engineer, you interact with different people at different levels, some of them technical, some of them non-technical, and the technical one, there are different levels of how technical they are, or they are technical in different areas. So you should know how to be able to communicate efficiently. And they talk about things like know your audience, know what you want to say, choose your moments, choose a style, make it look good, all these tips. So for instance, if you're speaking or telling, okay, let me pick 2 examples. Say you're telling something to people in your team, in your Android team. Let's talk about one stack. How you communicate to probably someone who's joined as an intern and how you communicate to someone who's, let's say, a senior in the team is not the same. So a senior has way more knowledge in that stack, so you don't need to use so many words or over-explain something. But for someone who started out, just throwing the jargon and leaving them to figure out is probably not going to be very helpful. You're going to have a bit more detail in explaining or communicating to them something. So know who you're communicating to and how you can communicate to them. A different example is, say, someone technical and someone non-technical. So someone in your team, again, and say you're doing a demo to a client. If you're working on a product that involves a client most of the time is probably not technical, and they are interested in the requirements, and if the requirements are working as expected. So saying during the demo day, there's an API throwing a 500 error, you're probably not going to tell them, oh, the API is throwing a 500 error, so we can't, that's why you can't see anything on the screen. You Something that makes more sense for them is probably the data for the recipes is currently not coming, being fetched properly, so we are going to fix that. Instead of telling them the API is returning a 500, what's an API, what's a 500 error? But if you're telling this to someone in your team or someone in the backend team, you can tell them X and Y API is returning a 500 error for them to be able to fix it. So context, who you're talking to, what are they interested in exactly, what makes sense to them, or what is their biggest interest in whatever discussion you're having, and what are the right words to communicate based on what they want. So yeah, all those tips, and choose your moment. So again, the human aspect of things, such that if you want to approach your boss, let's say on a salary review, probably the best time is not when they've been called that their son is in hospital and they're rushing out, and then that's the time you're telling them, oh, you're supposed to have a meeting. It's probably not going to be as fruitful as if you chose a time where their mind is settled or something like that. So choosing the right moment to also communicate. Yeah. Oh, yes. Something I found also really a great tip for communication is, so the tips that we've talked about is what you need to do. Okay, all of them are like that. But um, so most of them are how you need to set up your communication so that they understand. But there are two tips that I really like. So being a good listener and also getting back to people. And they were portraying it from the aspect of, if you're someone who's a good listener or who listens to what the other party has to say, and you get back to them. So when they communicate or reach out on something, you get back. And also when they're talking to you, you listen actively. It will also be easier for you to convey any communication to them, because um, most of the time someone will feel the need, or will feel obliged to also listen to you, because they feel like you listen to me every time I have something to say, or when I reach out for feedback, you're quick to give me feedback. So when you're doing the same for them, when you're trying to communicate something or give feedback, it's going to be well received on the other end. So away from learning how to communicate, also be a good listener and also get back to the other people. And the last bit they talked about in the communication subchapter is documentation. So the importance of documentation and writing relevant documentation. So for example, following the DRY principle, not repeating yourself, do not repeat yourself principle, in the sense of your documentation should not be something someone can already read in the code. For example, this variable, you subtract it from this. That's not what your documentation should be. So document what's relevant. So they are saying, discussing why something is done, its purpose, and its goal. And I remember when reading this subchapter, I thought about how the more I've stayed in this field, the more I've come to appreciate documentation, and not specifically in code per se. Sometimes it's documentation in terms of the overall architecture of the systems of a company. How do all these systems work together? So if you're joining as a team, it's something that allows you to put pieces together very quickly, but also now documentation in depth on each of these things, why some of the major decisions are the way they are. But also now, when you narrow down to the code, I think something that, let me give you an example. For example, the libraries you use in your code base, it's it's so great when you can probably use a library, click on a function in your development environment, and find what exactly it's doing. For example, if you're stuck on using a certain function, as opposed to just going and looking for, if it's an open source project, where the repo is and checking how this function works, or having to Google how it works on the online documentation. Sometimes when you can find it in code, that really helps. And I can probably give an example of, for example, in the Kotlin standard libraries, there are two functions that I always forget the difference. So in terms of strings, based on the use case, sometimes you want to check a string, so you can use a function called isEmpty, the string dot is empty, or string dot is blank. So I always forget what the difference between these two are, and I have checked so many times. This is not the first time it's not really the first time I've checked this. So every time I go to Google and check the difference, I find like 15 purple links because I have checked this before for sure, but I've forgotten what the difference is. So it's very easy for me to just write is blank in my Android Studio, click on it and find the documentation on, oh yeah, is blank, checks to ensure they are specifically characters. Is empty, factors in characters or white spaces. So from that perspective, as a developer, I've come to appreciate libraries that actually are well documented. So yeah, I liked that bit of explanation. And oh yeah, that's actually our last chapter, sub-chapter in chapter 1. So yes, that's the end of chapter 1 and what I picked from the different topics in the chapter. Yeah, so I guess that's the end of this video, but I'd really love your feedback or thoughts on the things that we have discussed from chapter 1. If you've read the book, or if you're in a position to, check out the book and read chapter 1, yeah, I'd really appreciate the comments on your thoughts on the different things. And yeah, so that's it for this video. If you got to this point of the video, thank you so much, and see you in the next video. Bye.